This is Chapter 1, Introduction to Statistics, Part 1. Reminder as we go through here, you can use the pause button to write down anything extra that you need to in case the video goes a little bit too fast for you. So statistics is a science, and it is about planning studies and experiments. Within that, we do a lot of things. One of the main things that we do is obtain data. Now, this course is going to touch very little on the actual obtaining of data. However, we are going to talk a lot about what we get from that data, the good data, the bad data, what it means, and things like that. So, while we're not going to actually obtain any data in this course, at the whole course in and of itself, we are going to talk a lot about the quality of that data. And then once we have that data, we get to do a lot of things with it. So it's a lot of ing words here: organizing, summarizing, presenting, analyzing, interpreting, and making inferences based on that data. So what we're going to do um, is a series of things. The organizing, summarizing, presenting, you've done some of that so far in your lives. You've taken numbers and summarize them by finding simple averages, things that you've done in grade school. Um, Presenting by making some tables and a pie chart, things that you've seen before. We're going to extend that a little bit further in this course, and then we're going to get into the meat and bones of this course, which is the analyzing it, interpreting it, and the big piece that we're going to spend about the back part of the course on is the making inferences based on the data. We're going to be able to take a data set and we're going to be able to make some grander inference about it. Now, there are two branches that this breaks into. So I could have started from this definition and broken it into the two different main types, and that is descriptive and inferential statistics. Descriptive statistics summarize the relevant characteristics data. That's that type that I talked about that you've probably already done. A lot of finding a mean, finding a median, finding a mode, things of that nature. Um, we're going to do a little bit of that. We're going to do a little bit of that in ways that you might not have seen, back in middle school or high school. But the main part of the course that we're going to focus on is the inferential statistics, which makes inferences about a population. Now, the key word there, population, what exactly does that mean? We're going to define that next. Um, I'm going to add the adjective target to it. A target population is the complete collection of all individuals that we want to make inferences on. So I start off here, and I want to give you a framing because we're going to get deep into the woods here, and I want to make sure you know where you are and where you're going. If we get too lost in all of that, you're not going to see the big picture. You're not going to be able to put things together, and the whole thing's not going to make sense. So I want to make sure we have a zoomed out view of what this course is. And so the idea is what we're trying to get to is this inferential statistics where we can make inferences about a population. Well, what is a population? A population is just that first part of the definition, the complete collection of individuals. It's everybody. So when we think of population, we mean just the all, the everybody. And we can use those terms synonymously. We will in this course. And notice I say individuals. That doesn't necessarily mean individual people. Okay, scores, people, measurements, buildings, anything. It doesn't really matter what it is. It's just things. So the population is the all the things that exist out there. And then the target population, we add that adjective target. It's who we want to make an inference on. And that's a subtle difference though. You have a population could be all people, but do I want to make an inference on all people, or am I only interested in a subset of people, say people who live in a certain place, or people who go to a certain school, or people who are, of childbearing age, or male, female, or whatever it may be. Um, and so we've started off with this idea of a target population that we want to make inferences on. So I want to clarify real quick, why can't we just get data on everybody? Why can't we make inferences on or why can't we just analyze the data for everyone? And that's what this whole course is about. If you think about what the word inference means, it means I am taking something small that I know a little bit about, and I'm using that to then help me make a decision about something bigger that I don't know about. When you make an inference about something, you don't have all the facts. And that's what this whole course is about, that we cannot get data on everybody in the world or every student in the country or every person of a childbearing age, in a state, whatever it may be. Oftentimes we can't get data on the everything. So what we have to do is we have to make an inference about that everything. Okay, and so that's kind of your framing for this idea. So if we were able to hypothetically get data from everybody, that is what's called a census. A census is a collection of data from every member of the population. Now, a census is something that's very hard to obtain. In fact, the US Census is not actually a census. We don't actually get data from every member of our population. We have people who are homeless and they don't get that envelope, and or you don't even have to send it back. Yes, you can register on the census online. What if you decide not to? Right? So the US Census aims to get data from every member of the population, but we actually don't do that. It's extremely hard to get a census. And so that's again where the point of this course comes in. And so what do we do instead? We take a sample. A sample is a sub-collection of members selected from a population, and that is what we're going to use to make an inference on the population. And so again, just some key terms, some key framing of where you're going. Keep this in the back of your mind throughout the entire course. It's going to loom large. Is we oftentimes can't get a census. We can't get data on everybody in the population or every building or every tree or whatever it may be. And so instead, what we have to do is we have to take a sample. We can get our hands on a small amount of data, a sub-collection, and we can make that to use an inference. Okay, but one of the key things that we're going to have to think about is how good is that sample? That's going to be a key point throughout this course. So again, your main idea, can't get data on the whole population. What do? I take a sample. I use that to help me make an inference about that population. But how good is my sample? And that's where this next term comes in. We are aiming for representative samples. And that means exactly what you think it would mean. It just means a sample where the characteristics of said sample match the characteristics of the target population. Is your sample looking like the actual population? If it does, then that's representative. If it doesn't, it's not. We need to ensure that our samples are representative. And now I want you to make a mental note here. You may want to highlight this in your notes. This is going to come up the entire rest of the year, and it's only day one. We're 7 minutes into this lecture on the first one that you're watching. And I'm telling you that students will lose points on exams 2 and 3 because they forget this point. And so it's something that I need you to remember, that one of the most important things in statistics is not, can I do this formula? We'll talk about this later, but I'm not that concerned about, can you do this formula right? That's a trait that I can teach anybody. What I'm concerned about is you thinking critically about, yeah, you've been given this sample, but is it representative of the population? And if it is, what does that mean? And if it's not, what does that mean? So that's something we have to keep in mind throughout this course as we're moving forward, is when I have a sample, is it a good sample? Do the characteristics match? And it's as straightforward as it sounds. Do the characteristics match? Is it the same groups of people with regards to, age, country of origin, gender, things of that nature? Do we have a similar breakdown? You would never want to take a sample of high school students and say that I can use that to make inferences on the entire state of Illinois. That wouldn't make any sense at all, because an entire state of people have people of all age ranges. So you want your sample to have people of all age ranges. Okay, so it's as straightforward as it sounds. So we'll look through a couple of examples here, and I'm going to pause a little bit myself, but you may want to hit the pause button as well to think through the answers before I go ahead and give the answers. This first one here says, a large community college has noticed that an increasing number of full-time students are working while attending school. The administration randomly selects 219 students and asks this question: how many hours per week do you work? And so remember, when we talk about a population and a sample, the population is the everybody and the sample is the subset that we're going to use to make an inference on that. And so the question becomes, what is the population? And the answer to that, when we answer population questions, it's really easy to just say all. It's the all blank, and you just got to say the blank. And so in this case, we're going to say the population is all students at this large community college. Now, that's the answer I chose. There are a lot of right answers to this question. There's a lot of wrong ones too, but there's a couple of different ways you can look at this. I don't want us to get too bogged down in the nitty gritty of it has to look exactly this way or exactly this way. It's a lot of, again, expanding your thinking. It's we could decide that we want our target population to be all students at any community college. Okay, that wouldn't be crazy. If we did that, we would want our sample to then get students from multiple community colleges. This question here says the administration randomly selects 219 students. We're going to infer that they're picking from this one college. That kind of leans me towards, well, the population needs to be all students at this one specific community college. And that goes back to what we were just talking about with, is our sample representative, does it match the target population? And there's a lot of ways that can look, and that's okay. The idea is that we want to try to match it up as closely as possible. And the way I'll explain it real quick is like this. You kind of can fix one thing and then everything else bounces off of that. If you start off and you say, I want to make an inference on students at this school, then that informs your decision. My sample needs to come from this school. Or you can go the other direction. You could say my sample happens to be of this school. Okay, that means I need to then make inferences on what I got from the sample. It's kind of a, just you can pick A, that leads you to B, or you can pick B and that leads you to A. It doesn't really matter. It just matters that they align. In this case, since we got students from this school, presumably, then that informs us that the population needs to be all students at this large community college. And of course, then our sample is just the who was the subset. This one, just pick out the number of people that we got. That's the 219. So I would say the 219 students sampled. Next example, the Gallup organization contacts a little over 1,000 teenagers live in the US and ask them whether or not they have been prescribed medications for any mental disorders. So again, when we're thinking about population, we're going to use an all word. Now, as we're thinking about this question, one thing that I want to point out that I want to make sure you catch is that defining the population is we need to explain all of the characteristics that everybody in the population and thus in the sample has. If the answer to a characteristic is some of them have it and some of them don't, that's not part of the population sample. That's a variable. That's a some have it, some don't. Okay, that's going to be a variable. That's going to be something that we're going to analyze. We list out all the characteristics of the population that everyone has. Okay, so for this one, my answer is going to read all teenagers who are between 13 and 17 and live in the US, because everyone in the sample has that characteristic. Notice some of them will have been prescribed medications and some of them will have not been, but because I can't say it applies to everyone, I don't label that as part of the population sample. And that's where people get tripped up right here, is they don't know this characteristic, should I put it in the population or not? Okay, and the answer to that question is very straightforward. It's, does everyone have it or everyone not have it? If so, then you can add that as a characteristic trait. If not, we want to leave that out. So yes, this talks about what we asked them. That's the variable. Okay, that's not part of the characteristics of the population. And of course, the sample, again, pretty straightforward. Just pick out the number, the 1,028 teenagers who were sampled. So we've identified population sample. Again, key concept. I'm going to repeat myself a little bit here, but again, just making sure we're all on the same term. The idea behind this course is that we're not actually able to get data on the entire population. We can't analyze that. It'd be nice to, but it's going to be infeasible. It's going to be too time consuming, too costly. So what we do, we take a sample and we're going to use that to make an inference on the population. But we're always asking ourselves, is this a good sample? Is it representative? Do the characteristics align? Okay.